Alright guys, so we're graphing secant and cosecant today, okay? Yesterday we did sine and cosine, today is secant and cosecant. So I made a little animation here to kind of help us go faster. So what I'm going to do is I'm going to simultaneously graph sine and cosecant. And the reason I'm going to do that is because the way that we're going to graph these functions today is based on what we learned yesterday with the other ones. And the reason we can do that is because sine and cosecant are reciprocals of each other. Okay, so they have a relationship there, and we're going to use that relationship to graph the cosecant function today. So let's go ahead and start at the top there. What's sine of 0? Now I'll help you out a little bit. Sine is the y value, and we know where 0 is out on the y on the unit circle. So what is sine of 0? 0. What's the reciprocal of 0?
0.
No.
It's
Undefined, right? All right, so I'm going to put a red dot there at the origin for 0, 0. That's for the sine graph. But cosecant is undefined there because there's no reciprocal of 0. So I'm going to put a blue dotted line. Cosecant actually has a vertical asymptote at that point. It doesn't exist at that value. Okay? Let's do the next one. Sine of pi over 6. Now that's a little bit more complicated. I'm just going to use decimals instead of the pi expressions, or the radical expressions, I mean. Oh, that one's actually pretty nice. It's 0.5. That's 1 over 2, right? What's the reciprocal of 1 over 2? 2. So I'm going to plot a red dot for the point pi over 6 and half for the sine function. But the reciprocal of cosecant is 2, so if I plot that, pi over 6 and 2, I get a blue dot right there. Okay? And I'm just going to continue doing that. So that's sine, and that's where that dot would go. The reciprocal of that is 1.4, and that's where that dot would go. Are you guys starting to see a little bit of a pattern there, maybe? It's like they're a reflection of each other almost, right? They're not, it's not really a reflection, but it's kind of like that. And the reason it's kind of like that is because they're reciprocals of each other. Now once again, when you get down here to pi, sine is 0 again, right? Yeah. And once again, that's undefined for cosecant. So cosecant's going to have another vertical asymptote there. So cosecant looks like this. Now it doesn't actually touch those blue lines, right? It just gets closer and closer to them, but never touches it. But that's what it looks like. And so we're going to use this fact to kind of graph cosecant today, and secant works the same way. What we're going to do is we're going to start by graphing sine and cosine first. And then all you have to do is you have to just put a little shape right above where the peaks are. And actually, even though I don't have the rest of it up here, you know how it dips down also, right? The same thing happens on the bottom. Okay? So cosecant and secant kind of end up having a shape that looks like this. So you see those red lines? It looks like a whole bunch of parabolas. They're not parabolas because parabolas don't have any asymptotes, but they kind of look the same in the short-term view there. Anyway, so sine equals 0 at 0, pi, and 2 pi, right? Those are all multiples of pi, like this is 0 pi, 1 pi, 2 pi. And anytime sine equals 0, cosecant's undefined. So at all those places where sine equals 0, cosecant's going to have a vertical asymptote. Now on a graph, how can you tell where a function equals 0 at on a graph?
Wait, when a function equals 0, it's a root?
That's right. So there it is. It's when it touches the x-axis, known as the roots. So look at these. You see these points here? This is a root of the sine wave. This is a root of the sine wave. Notice that that's where the cosecant function has its vertical asymptotes. Okay? So anywhere where sine has a root, cosecant has a vertical asymptote. The same thing happens for cosine, because sine and cosine are pretty much the same thing, and so the reciprocals are going to look pretty much the same. But remember, they start at different points, and therefore the asymptotes will be at different places. Cosine is equal to 0 at pi over 2, 3 pi over 2, and 5 pi over 2. And in case you don't notice that the pattern here is odd multiples of pi over 2, like this is 1 pi over 2, 3 pi over 2, 5 pi over 2. The next one would be 7 pi over 2, and so on. So any odd multiple of pi over 2 is going to give you a vertical asymptote for the secant wave. So once again, over here I've got a picture of a cosine wave, and that's the roots, right? And notice where that cosine wave has roots, the parabolas, is those secant waves, have vertical asymptotes. But the shapes are pretty much the same once again, it's just that they have different starting points. Okay, so what we're going to do to graph these today is we're going to just start by graphing a sine or a cosine wave. So for instance, if you see secant, what we're going to do is we're going to actually pretend for a second that it's cosine. And we're going to graph a cosine wave just like we did yesterday. And then when we're all done, we're going to find out where it touches the x-axis, and in all those spots we're going to put some vertical asymptotes in, because the actual secant graph has vertical asymptotes at those points. And then after that we're just going to sketch the curves by hand, and we'll do that. That'll be the secant wave. So that's the idea. So let's go ahead and jump on in here with example 1. Go ahead and write down your directions in number 1.
What's your room number?
323. 4K.
Oh.
All right, so 3 cosecant theta plus 2. Okay. So first of all, we're gonna graph the reciprocal of cosecant first. Okay. So what's the reciprocal of cosecant? You guys forgot. It's sine. Okay. So we're gonna graph the sine wave really quick. Okay, so how do we do that? Well, we start by putting our angles on here. Our angles are pi over 2, pi, 3 pi over 2, and 2 pi. Now, where's my midline? Good. And I'm going to move this down if I can. Well, let me take just that. All right. And my amplitude is 3, right? So where's my maximum going to be?
Oh,
Okay, 3, 4, 5. And where's my minimum going to be? -1. And with sine, where do we start? Max, midline, or minimum? Midline. And there's no negative in front, so we go up, right? So it's going to be over and up, over and down, over, down, over, up. And there's my sine wave. And then we can go ahead and just kind of continue the pattern here. So that's just all review from yesterday. Oh, come on, you're here. I think I marked you absent. I'm going to fix that. Yeah.
Wait, so you don't go down the minimum?
Oh, I screwed up, didn't I? Thank you for noticing. I didn't do this correct, guys, because Pearl had noticed that I went down to the x-axis. That's a tempting thing to do, but I was supposed to go down to my minimum. So I'm going to correct that. So I need to take this dot here and bring it down to here instead. I don't want to go there. So it's going to be like this. All right, there we go. Thanks, Pearl. All right. Yeah.
So on like tests and stuff, should we find the points on the other side of the y-axis as well? Or are we allowed to just?
No, I'm good with just the 4 that we've been using. Can't hurt to do that. Be a good exercise, but it's not. I'm not going to grade you on it. All right. So now this is not our answer though, right? Because this is a sine wave. Really, I want to graph a. Well, I can't scroll up, but I want to graph that cosecant wave, right? So to do that, we need vertical asymptotes. And where do we say those vertical asymptotes we're going to be at? At the roots. Now, it was really, I guess a better way to say this would be at the midline, right? Because on the one that we looked at originally, the midline was the x-axis. So it's actually at the midline. So what I want you guys to do is I want you guys to put a, we're going to have a vertical asymptote everywhere this sine wave is hitting the midline. Okay? So let's do that. We're going to put a vertical asymptote here, here, anywhere where there is a place where that sine wave hits its midline. We're going to put a vertical asymptote. So many ugly things here. It's kind of all messy now. That's why I'm trying to use different colors. All right, so let's take a look in between these first two. So you guys see this peak right here? What we're going to do is we're going to draw a little parabola that hits that peak and just comes right back up and stays in between those asymptotes. And you're going to do the same thing down here between these two asymptotes at this bottom piece. So it's going to go like this. And the next one's going to go like this, and so on. All those lines driving you nuts? Yeah, it's ugly. If you want to draw them really light and just erase them afterwards, because really all you need is this, these little U shapes, because the U shapes are the secant, are the cosecant graph. The rest of those things are just guidelines we use to find out where to put stuff. Okay. All right, so there you guys have it. That's how you graph one. Let's do a guided practice and then a student practice, and then we'll call it a day. Hopefully we can finish early so I get my other classes caught up. You guys ready? All right. Go ahead and write down number 2. This can be a guided practice, which means I'm going to let you guys do it step by step, and I'll let you check your work with me as we go. But the last one we'll make an actual student practice. We'll see. If you need more practice, we have time. But if you guys nail number 3 and looks like you know what you're doing, we'll have a little bit of extra time to go. So we're just doing number 2. So, all right. So here's the first thing I want you guys to do. 1/2 secant theta minus 3. The first thing I want you to do is I want you guys to rewrite this equation with the reciprocal function in there instead. Just like I did on my last one there. So go ahead and do that. And then I'll call on somebody to tell me what they wrote. So we're not going to start with secant, right? We're going to start by graphing the reciprocal. So I want you to rewrite the equation with the reciprocal function in there. Instead, isn't that it? Or did I rewrite it wrong?
That's it? Yeah, that's it. What did I write?
Yes. All right. So Pearl, what did you write? Okay, guys, that's correct. The reciprocal of secant is cosine. So we're going to start by graphing this, and then that'll help us get the one we actually want. All right, so let's move on now. I want you guys to go ahead and graph your cosine wave at this time. I'll give you a little bit of time for that. That'll take a few moments. So go ahead and graph your cosine.
Bro, I need it to be bigger. case I can see where the delete pivots and those
Okay. Get started here.
yes, I got
All right, and so we're going to ask, this is just review questions, but it's a good opportunity to get some points anyway. So, Cameron, what's our midline?
Midline is
Okay, 1, 2, 3. Anytime I know that my amplitude's a half, I try to make the spaces between the numbers a little bit bigger because it gets kind of hard to graph them when it's so smashed. Sydney, where is the maximum at?
I don't know, it's half, right?
Yeah, so we're gonna go up a half. So it's here, right? So that would be negative 2.5? Okay. That's right. And the minimum? Ezekiel, what's the minimum? Yeah. There's that. All right. Now we're going to go in graph. So this is cosine. So Justin, where do we start? Do I start at the max line, the midline, or the minimum line? Max. And then we go over and down, over and down, over and back up, over and back up. And so we have our cosine curve here. So that's what our cosine curve should have looked like. All right, so now what I want you guys to do is I want you to see if you can find where those vertical asymptotes go. See if you can put them on there. I'll give you a few moments for that. It's where the cosine curve hits that midline. So you want to get your vertical asymptotes on there. Okay, so it's everywhere where the sine wave hits that midline. Did I say sine? Cosine. Everywhere where the cosine touches the midline. And so what I'm going to do now is I'm going to put these little vertical asymptotes everywhere cosine hits the midline. And then we're going to put our waves on there. So that part, I think you guys can probably handle that. So I'm going to go ahead and get started there. That. It should technically touch the top of the cosine wave. There shouldn't be any distance there, just so you know. And there's our secant waves. That's it. Pretty chill, eh? Okay, I'm gonna let you guys just do one completely on your own, and then I'll check your work after about 5 minutes, and then if it looks like you're good, we'll call it a day. If it looks like we need some more practice, we'll try some more. Ready? All right.
So how many units is this chapter?
How
many lessons is this unit?
This chapter has maybe like, I want to say like anywhere from 6 to 8.
Okay.
So. All right, so there you go. Number 3. You guys try number 3 out. So the reciprocal for secant is cosine. And our midline is going to be at 1, and my max is going to be at 2, and my minimum is going to be back at 0. And Jennifer, where do we start for a negative cosine? At the minimum, right down here, right? So we go over and up, over and up, over and down, over and down. So this is what your first curve should look like. Okay. So something you want to check in your work right now is, did you start at the bottom instead of the top or the midline? Make sure you start at the right spot. After that, you can go ahead and complete the curve, just keep it going. And then we need to put our vertical asymptotes in there. That's everywhere where it touches the midline. So and then you go ahead and throw the the secant curves on there. And there's our final answer. Okay? All right, so that's where we'll call it a day. If anybody wants to see the homework and maybe start some in class, you can. I'll start it here and then just take a picture and pass it around. Huh? No, he is on some kind of vacation or something. I don't know. But he's still here.
You're not doing these. You're not doing these. You're still inside yours. Actually, you're telling me. No, honestly, I'm not.
Would you like?
Yeah, okay.
Probably because I have no time.
I'll take your